Hello, this is Steez. Welcome to the first video actually on this channel of mine. I actually have another YouTube channel where I play video games, but I haven't posted on that in a long time, so I'd probably find it very rare if anyone knew who I was, but that channel is Steez Gaming if anyone's interested to go check it out. I used to play Call of Duty a lot, but as of lately I've been teaching myself programming, and I started out just for fun, and it just kept going from there, and now I'm really getting into it and maybe potentially making a career change out of it. But this video is going to be a demonstration of my solution that I developed maybe 2 months ago for Project Euler number 4. For those of you who are unfamiliar with Project Euler, they're this set of online problems that are easily solved with computer science, and would some would say probably very hard to solve without a computer. So they're used to test your programming knowledge. This one is actually really interesting. I'm starting at number 4 because the others were kind of boring up till now, but this one is a palindromic number reads the same both ways. The largest palindrome made from the product of a 2-digit number is 9009, or 91 times 99. And so our job is to find the largest palindrome made from the product of 2 3-digit numbers, or 100 to 999. So I'm very new at programming, I would say, and so I welcome those of you who are new at programming to ask me as many questions as possible, but I'm sure that the solution I implemented like a month or 2 into my learning is not the most ideal. I know that, and some of the things that I've been using here were like to train myself. But let's get started. So this is Java, and I'm using Eclipse, by the way. I've been, I learned a little bit of C in the beginning, but I've been training in Java as of late, just because it's sort of a more well-rounded language, and I can talk about this in a little more depth. I'm going to make probably an introduction video should this channel take off, and I'll tell you all about myself and my studies and endeavors and interests and loves and likes and whatever. So let's get started solving this problem in Java. So what we want to do, I've created this simple class file, and it's called palindrome.java. And in the interest of full disclosure, I've actually already solved this, so I'm going to be walking you through the code, and in that way it'll almost be a little more concise than it would be if I had tried to figure it out all myself. So let's get a main function going here. We'll declare a main function, public static main void string. This is all just boilerplate stuff if you're new. Oops, I got these mixed up. That's silly. Public static void main. And the first thing I did to solve this problem was I declared a Arraylist, which is it's a library in Java from the collections framework, and this is done so by declaring the type of collection you want, a list, and we're going to put integers inside of that. And let's call this list palindromes, because this is going to be the data structure that I use to store all of the solutions, or all of the numbers that fulfill the palindrome test of being equal in both directions. So this is how you create such collection, and we're going to hit Control-Shift-O in Eclipse, which brings the import in, and we're going to use the first one there, Java util.list. See how it brings it in automatically up top? It's really nice hitting Control-Shift-O. And I'm also going to create an object, an integer object, and I'm intentionally not using the primitive for reasons that you'll see later, but it's really just because I want to be able to, I mean, I don't know, obviously I'm new at programming, but we're going to call this product, and we're going to say product gets new integer, and we're going to initialize this to 0 for fun. Just so it's not null for any reason, although I don't even know if you can declare an integer without the constructor having an argument. But so we have to figure out palindromes from 100 to 999. So we're going to start off with a for loop here, and this is the basics of the entire solution. well, the beginning of it, I guess. We're going to generate a set of products from this for loop to a nested for loop. So we're going to declare an int I gets 999. As long as I is greater than 99, which is obviously, I'm working backwards from 999, by the way, which I'll explain in a bit. Then we're going to decrement I, and then inside of this loop, we're going to have the second number that we're multiplying to create the product. We'll call this integer j gets the same, 999, and as long as j is greater than 99, then decrement it. As so. Boom. All right. Now, this is essentially just going to, the first iteration throw is going to take 999, multiply that by 999, and ask, is this a palindrome? And if it's not, it's going to keep going, and j is going to decrement to 998, and it'll do 999 times 998, and ask the computer, is this a palindrome? And it's going to go like that until it decides that something is a palindrome. So we're going to take our product, which I declared as a, not a global, but whatever in the scope of this main function. We're going to set product to equal j times I. And then we're going to do the check of whether or not it's palindrome. So we'll say, I didn't develop this function yet at all, actually. So, but this is going to be is palindrome, and we're going to pass to that function the product. And if it is, then we're going to add that palindrome. We're going to add that product to the palindrome array list that I created earlier. And then we're going to break. And now this break is going to break us out of the inner for loop. So then we'll then go 998 times 999, etc. Now this is very inefficient because we're going to have some duplicate products come through, but the solution to the problem is only what the largest palindrome is. If that's a duplicate product, it really doesn't matter at all because we're just going to grab the largest number. And so once this whole thing is completed, then inside of our main function, which of these curly brackets is, I'm going to highlight that. Okay, so it's this one. So inside of this main function, then we're going to sort our collection because the way that I'm doing this, they're going to come out completely unsorted, or not entirely unsorted, but they'll be relatively unsorted. So we're going to sort this array list of palindromes. I have to import collections, so I'll hit Control-Shift-O and select the most obvious import there, and I believe that is correct. It's still giving me the error here because I haven't defined the function is palindrome yet. But the last thing we're going to want to do is system out. Now, notice I'll do this for the beginners of Eclipse or Java or whatever. I don't know what level programming you guys are coming from, but what you can do in Eclipse, which is really handy, and probably some other editors, is you can hit sysout. You type in sysout, which is really quick, and then you hit Control, or is that Control space, and it automatically does a system.print.out.println. This is the same in C as what would one say is printf. It's the same in PHP. It's echo. It's really just the most simple printing function, and we're going to pass to our array of palindromes. Okay, good. So that's going to iterate through all the possible multiples of any 3-digit number. And then what we're going to do after this is define the logic. This is the fun part right here of the Euler problem. We're going to say, how do we figure out if something's a palindrome? So I'm going to declare that function public static boolean because we want to return true for this if loop, or not a loop, this if statement is palindrome. And into this we're receiving a integer product. So we want to declare an integer, and we'll call this product as well, just for the sake of memory. This is actually, you know what I'll do? I'll call it something different just because I don't want to get this confused, even though they are in completely different scopes, which is a topic that if you're new to any programming language, scope just means that this number will only exist between the parentheses that I define for this function. So outside of this number that I've declared means nothing. And the only thing that this thing can see are global variables and things that I've passed to it. Okay. So this is going to be fun. Now, the way I implemented this was a kind of roundabout way, but it's the way I did it, so you can judge me later. But so what I'm doing is I'm first creating a string, which is just a sequence of text characters for those who are unfamiliar with programming. And we're going to call this number string because it's going to take in the number product as a string. And the way we do that is we say number, which is this variable here, and we'll do the toString method. So that takes the number, for argument's sake, let's create just something for demonstration purposes, 9880889. Okay, boom. It takes this as an integer and it turns it into this as a string. Okay. And then the next thing we're going to do is we're going to figure out how long this is, just so we can implement size later. And we're declaring the length function on the string that we just created, which, in this case would return 1, 2, 3, 4, 5, 6, 7. So that's just going to be a variable that's easy to reference by the word size later instead of declaring the whole function over and over again. The next thing I'm going to do is generate some data structures that we're going to use to kind of do workup on our some data structures that we're going to work up on our number here. Okay, so we're going to create a character array. Now I'm calling it character array because I'm going to take that string and turn it into an array of characters, which I'm going to do immediately here. numString.to character array. And so what this does is it takes our 98809 and it turns it into something like this, where these are each characters, but it's going to take it 9880, but these aren't numbers, these are understood as characters in the computer's mind. You wouldn't be able to multiply the character 9 by the character 8 and expect whatever that is. What is that, 84? Is that, God, I can't believe I don't know my multiplication. But it's understanding it like it understands the letter A, for example. The next thing we're going to do is declare an array called number array. So what we're going to do is turn this character array into an array of numbers that we can then compare against each other to determine if the initial number is actually a palindrome. I don't know why I did it this way, but I kind of declared it separately. This was just probably something where I was thinking it out, but this is what it is for the sake of making sure there's no errors later. Oops, this is supposed to be size. So I'm creating a new number array of size, which we know as 7. And then comes the fun part. So what I'm going to do with this next, I'm going to create a for loop, and I'm going to iterate through the character array and turn each of these, which are listed in here as strings, into digits. Then I'm going to convert to numbers for our number array. So we'll get the integer I, and this is a different I, by the way, than the one above because of scope, as I mentioned before. As long as I is less than the size of the array, we're going to increment it like so. And then inside of here, we're going to declare a new variable, which I'll just call digit because it's a single, digit, but it's a string. Keep that in mind. And we're going to declare a function that's of the character class, toString, and it takes in a character. So we're going to pass into that the ith letter in our character array. Okay, so this is just pretty simple. It's just iterating through the character array, which, if you remember, is just 9880, etc., and turning that into a digit. That's understood as a string. So I'm taking a character and turning it into a string because of the function I'm going to declare next, which is this. Num array, so we're going to populate num array now, of I, so the ith value in the number array, gets integer.parse as int, parse int. And we're going to pass to that digit. So this is actually a really handy function. It takes a string and that string is just a single digit, and it parses it in as an integer. But this integer is then an array. So what we have now are actual, like, we have an array of integers of, 9, the number, 8, 8, dot, 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 like that. And now we can do some logic on that. So now is the fun part. Are you guys ready? You ready? This is the logic of the problem. Now remember, we're trying to figure out if any given number that's passed to the function is palindrome, if any given number is a palindrome. So how do we go about doing that? Well, we want to compare the beginning of the number to the end of the number and ask ourselves, is that the same thing? And if it is, then we want to keep going. And if it's not, then we want to tell the function to return false because it's not a palindrome. So let's start with a for loop again. We're going to declare an int j because we can't use I again because of the scope I is already used. And we're going to set that equal to 0 and j less than size, which we know is 7 for our particular 9880889 example, which should return true in this case because it is a palindrome. And we're going to increment j. This is just a standard for loop. Oh my god. Where is the pluses? There they are. So inside this loop, I'm going to declare two variables that, by naming them as such, should be evident what they stand for. We're going to declare an integer called head, and this is going to be the number array. This is going to be the beginning, so the number array of j. We're going to declare another int tail, which is the last number of the said potential palindrome candidate. And this is going to be num array. Now here comes this is a little tough, the logic here, but essentially to define this, working with the off by 1 sort of function of our j starts at 0. What we want to do is we want to define j as the size of the function minus j, which starts out as 0, and then we want to subtract 1 to get rid of the off by 1 error developed by our for loop. And then we want to ask ourselves, so in this case, by the way, the tail is 9, tail is equal to 9, and the head is also equal to 9 in the case of our number. Just, they're going to be the same thing, but we want to check from both ends, as I mentioned before. So now we just ask ourselves some questions. If the tail is equal to the head, then we want to keep going, essentially, and check the next section. Then, so we'll just say continue, because it worked, and it'll just iterate to the next for loop, and it'll then compare 8 to 8, and it'll keep going. Now, for instance, we're going to say else if the tail is not equal to the head, in which case it's not a palindrome, then we want to return false and tell the function that's asking this that it's not a palindrome at all. And then lastly, should it pass the entire test, then we're going to want to return true. So for instance, if we get to the entire end of the for loop and tail is equal to head, etc., we're just going to return true. In fact, I'm not even sure if this is necessary at all. I think I'm just putting this in here as an accident. This is probably an unnecessary step, because even if we get to the very end of it, maybe I can test this later. Even if we get to the very end of this, it should have returned true all the way through to the end, at which case it'll return true at the very end of the function should it get here. But for now, we'll put this in because this is what I said. I did this problem, back before I learned a lot more, trust me. So if there is an error, it's my future self's fault. And then lastly, we're going to get out of this for loop, and if we've gotten here, it means that the function is true because we've tested against the possibility that it's not. I'm sure there's some example that maybe wouldn't test through this very well, But that's essentially the end of the function. So let's go back to our main function here where we've got our list of palindromes, we've got our product. It's going to iterate through all the possible permutations of a 3-digit number times another 3-digit number. But it's only really it's not going to get all of them. It's only going to find the largest for any given iteration of the decrement of I. And then it's going to store that into an array called palindromes, and then we're going to print that out. And so the solution should be the largest palindrome. Okay, so let's test this out. I think it should work. I don't see any errors. And let's hit play and see what it says. I want to make sure you guys can actually see the console here. Yes, you can. Okay, so let's see. Play. This is the fun part, the moment of truth. There we go. That was pretty quick. Sometimes these project Eulers can take a couple minutes. They say there's a minute rule. By the way, this is a spoiler alert for anyone who hasn't done this yet. If you don't want to see the answer, you don't want to know, don't look. But the answer here, so this is sorted in descending order. So if you notice, each of these is a palindrome 2772, 29892. It's actually pretty cool. But the largest one here in our array is 906. Oops. Somehow it skipped back. The largest one in our array is 906609, and that is actually the correct solution. So that was my function is palindrome, or palindrome.java for Project Euler 4, and I will probably put this source code on GitHub at some point so you guys can poke around if you want. But what I wanted to do before I let you go is test if I actually even need to have this in here, and I'm suspecting that I don't. So let's comment this out for now. I think this was just a new mistake back when I developed this. It should still return the array as is, and it does. So essentially this was unnecessary, just me being hyper careful and thinking maybe that I needed an else loop. I don't know. Beginner's mistake. Now, going through this, now that I've had a little more experience, I know that there's some optimizations I can make. Like, for instance, I'm checking through the entire number where I really only need to check through the first half of the number. Like, the half of the number plus 1 would be good enough to determine if the number is in fact a palindrome. I don't really need to check any further than that, and that's an optimization that one might make if you were trying to check, say, the combination of any 4 or 5-digit number where you're getting these gigantic products. But for ours, it worked pretty quickly without any of these optimizations. And so that was Project Euler 4. Hope you guys enjoyed. Please like the video if you found this enjoyable or anything. I mean, it is my first, so if you want me to continue to make these, please let me know. And enjoy your coding experiences in the future. Cheers.